Rewind is a 3-year research project funded by the European Commission within the Future and Emerging Technologies Initiative of FP7, Information Society Technologies Program. The project started in May 2011 and will end on April 2014. Investigating the past history of objects, either natural or man-made, given just a few clues collected at present time, is a challenging research topic in many fields of science. In geology, for example, the analysis of rock fragments allows us to look back into the geological history of entire regions. In life science, genomic studies allows us to trace back the evolution of living species. In computer science, software products are reverse engineered in order to obtain information on the original source code. As computing systems grow in power and devices for acquiring audiovisual data become more and more widespread and accessible, multimedia digital objects, especially audio and video, become easier to create, store, transmit, modify, and, well, to tamper with. The need of methods and tools that enable a reverse engineering of audio-video data is therefore becoming more and more of an urgent necessity. The Rewind project is aimed at combining principles of signal processing, machine learning, and information theory to answer relevant questions on the past history of such objects. During its lifetime, a multimedia object might go through several processing stages, including multiple analog to digital and digital to analog conversions, coding, decoding, transmission, editing. As such, the history of multimedia objects can be described in terms of complex processing chains. The Rewind project relies on the fact that each one of these processing steps is bound to leave a characteristic footprint that can be detected and analyzed to trace back the past history of the considered multimedia objects. Conventionally, these footprints are deemed as misprint of the multimedia processing chains. Considerable effort in multimedia processing research has been directed towards preventing these artifacts through, for instance, sophisticated sampling and interpolation methods, error resilience mechanisms, or techniques to avoid undesired or unauthorized modification of the content streams. In the Rewind projects, this perspective is completely reversed. Footprints are here considered as an asset, in other words, as a precious source of information on the history of the multimedia objects, which can be leveraged to reconstruct the processing chain. The Rewind project will develop a comprehensive set of new mathematical models and techniques that address the footprint detection problem, irrespective of the number of the processing stages the data goes through and of the media involved. This will allow us to pave the way to a universal theory of footprint detection and identification, which will be applicable to complex processing chains involving composite objects. The methodologies that will be developed within the Rewind project will have a significant impact on many areas of multimedia signal processing, including, for example, multimedia quality assessment when no reference techniques must be used, multimedia forensics, multimedia restoration, near duplicate detection of a digital content on large digital libraries, and so on. Among the objectives of the Rewind project, there is also the rapid and immediate dissemination of the research results. Therefore, the Rewind Consortium invites those who will visit this website to browse the various sections to learn more on the project results.